Welcome to The Explainer. Today, we're diving into something pretty huge in the world of AI. How we're finally letting these powerful models out of their digital cages to actually interact with the real world. We're going to break down the new standard that makes this possible, and why it's both an absolute game changer and, well, a pretty major risk.
So let's just jump right in. You've heard about these incredibly powerful AI models, right? Well, they all have this one fundamental issue. People call it the brain in a jar problem. Think about it. They're geniuses, but they're trapped. They can write you a poem or ace an exam, no problem. But ask them what the weather is right now or to book you a flight? Nope, can't do it. They're completely cut off from any live, real-world information.
Okay, so here's what we're going to cover. First, we'll talk about this walled garden the AI lives in. Then, how we're starting to break it out using tools. We'll look at the universal connector that keeps it all from becoming a chaotic mess. After that, we'll get into the good, the bad, and the ugly, the promise and the peril. We'll explore the serious new security risks, and finally, how we can actually try to tame these powerful new agents.
All right, first stop, the AI's walled garden. This really gets to the heart of the problem. These models are fundamentally stuck, limited only to whatever they learned during their training.
So, how do we get them out of that garden? Well, that brings us to our next part, unlocking the real world. And the answer, really, is to give the AI what we call tools, to act as its eyes and its hands.
Okay, but what is an AI tool really? Well, you can just think of it as a special program that the AI can call on to do something that it can't do by itself. The analogy on the slide is perfect, actually. They're just like apps on your smartphone. Your phone is powerful on its own, but it's the apps that let you do almost anything. It's the exact same idea here.
And here's a great simple example of this in action. You ask, what's the weather? Seems easy, right? But for an AI agent, it's a whole chain of events. It has to grab a tool to figure out where you are. Then it uses another tool to call a weather API and get the data for that spot. And maybe even a third tool to convert from Celsius to Fahrenheit. The AI model itself, it couldn't do any of those steps alone. It's all about using the right tools for the job.
Okay, so tools are great, but this creates a whole new headache. Imagine if every single AI model needed a unique, custom-built adapter for every single tool out there. It would be an absolute mess, total chaos. And that's where our next big idea comes in, the Universal AI Connector. We're talking about something called the Model Context Protocol, or MCP for short.
This is what developers call the N by M integration problem. The N is the number of AI models, and the M is the number of tools. Every time you add a new model or a new tool, the amount of work you have to do to connect everything it explodes. It's a nightmare. You just can't scale that way.
And this is exactly what the Model Context Protocol was designed to fix. It's an open standard. You can think of it like a USB port for AI tools. It's a universal plug-and-play interface. So suddenly, any AI can talk to any tool. No custom wiring needed. It's a universal translator.
And the way it works is actually pretty clever. You've got the host, that's the app you're actually using. Inside it, a client sends out standardized commands. These commands go to an MCP server, and that server is the thing that actually holds all the tools and does the heavy lifting. The key here is that the AI app and the tools are kept totally separate, which is a really clean and flexible design.
So that brings us to the next big question. What does this all mean in practice? Let's talk about the promise, the peril, and the performance. Because whenever you create a universal standard for something this powerful, you're going to get some amazing benefits, but also some really serious drawbacks.
I mean, on the promise side, the wins are huge. We're talking about a true plug-and-play world for AI. Development gets way, way faster. AI agents can literally discover new tools on the fly as they need them, and you can swap different models or tools in and out without rewriting everything. It's just a massive unlock for flexibility and raw innovation.
But, and this is a big but, there's the other side of the coin. For one, if you give an AI too many tools to think about, you can actually overload its short-term memory, its context window, and literally make it dumber. Then there's the fact that the basic protocol is missing some really crucial stuff for big companies like built-in security and authentication. And maybe the scariest part, it opens up a Pandora's box of brand new security holes.
And this chart right here tells you everything you need to know. Just look at it. The MCP standard can handle a whole bunch of different things, right? Prompts, resources, all that. But what are developers actually using it for? Tools. Almost 99%. Everything else is barely getting touched. That tells you exactly where the energy is right now, but it also screams that this ecosystem is still super, super new.
Okay, let's zoom in on that last point, because this is critical. A new world of risk. We have to understand that when we give an AI the power to do things in the real world, we're also handing attackers a whole new playbook for causing some serious damage. Check this out. This is a nasty one called tool shadowing. An attacker makes a fake tool, but gives it a description that sounds completely harmless, maybe even more helpful than the real one. So you tell the AI, hey, save this file. The AI, trying to be helpful, might pick the malicious tool because its description sounds a little better. And just like that, your sensitive data gets sent directly to the bad guys.
All right, now let's talk about a classic security nightmare that's getting a terrifying new life with AI. It's called the confused deputy problem, and it all starts with a prompt that looks totally innocent, just like this one from an attacker.
So what's happening here? It's so clever and so dangerous. The AI itself doesn't have any special permissions. It's just a go-between, a messenger. It doesn't know the attacker isn't supposed to access that secret file. It just says, okay, you got it, and passes the command along to the MCP server. But here's the kicker. The server is highly privileged. It has the keys to the kingdom. So the server, our confused deputy, gets this command from a trusted source, the AI, and just executes it. It never checks who the original request came from. And boom, the company's most secret code can just walk right out the front door.
Okay, that's pretty scary stuff. But it's not hopeless. There are ways to fight back. Which brings us to our final section, taming the AI agents, and how we can build systems that are secure and reliable.
So here's the bottom line. The MCP protocol itself doesn't have a lot of security built in. That means it's on the companies building these systems to add their own layers of protection. We're talking about the fundamentals of good security, really. Only use pre-approved tools from an allow list, make a real person click OK before the AI does something high risk, clean up every piece of data that comes in or goes out, and maybe most importantly, follow the principle of least privilege. That means no tool or agent gets more power than it absolutely needs to do its job. Period.
And that really leaves us with the big central question for this whole new chapter in AI, doesn't it? As we connect these models to the real world, we're giving them an immense amount of power. The real challenge for all of us isn't just about building the coolest, most innovative tools. It's about building the guardrails to make sure all that power is used responsibly and not recklessly.